Write an equivalent expression to the expression below using only addition. You do not need to evaluate the expression. In order to rewrite this expression using only addition, we want to follow our rule for changing an integer subtraction problem to an integer addition problem. The reason we do this is because sometimes it's easier to subtract if we think of subtraction as the same as adding the opposite of the integer which we are subtracting. Your first step is to change all the subtraction to addition. So every subtraction sign in this problem is going to get turned into an addition sign. But you also have to change the sign of the second number. And the reason why we have to do that is because we have to make sure we still get the same value when we're done. So not only do we change the subtraction signs to addition, but then we have to take the opposite of that number that we were subtracting. So let's start writing this. We have 13, and that first subtraction sign is going to turn to addition. But the 4 we were subtracting, we need to change it to its opposite, which is a -4. The second subtraction sign will also change to addition, and then we have to take the opposite of the 6, which is -6. The +8 stays the same, and that last subtraction sign we turn to addition, and then we turn the 2 into a -2. Now, the problem said you don't need to evaluate the expression, but it might be a good idea just to evaluate the original expression and to evaluate our new expression to make sure we get the same result, because if not, we made a mistake somewhere. So if you go from left to right in the first original expression, because it's just adding and subtracting, you would go left to right. It would equal 9. Now, if you look below in our final answer, and if you were to add up all those numbers, if you add up all those positive and negative numbers, you still get 9. So we know that we've created an equivalent expression using only addition.